Hello calculus learners. In this video we're going to talk about basic derivative rules, okay? And if you remember that in the previous lesson we've talked about how to find the slope of a curve at a particular point, how to find the derivative of a function and evaluate it at a specific point using the limit approach. But in this case, in this video, I'm going to give you very basic shortcut ways of finding the derivative of polynomial functions, okay? So let's get started. So the very first rule is when you take the derivative of a constant number, the derivative is going to be always 0, which means d over dx, it could be like 1 million, okay, but the derivative still is going to be equal to just 0. And the second rule that we're going to use it a lot, that we're going to make great use of it a lot, which is the power rule. So it says d over dx, x to the power of n, is going to be equal to n times x to the power of n minus 1, which means in this case you're going to take this n down here and put it out front of x, and you're going to decrease the degree of this x by 1. So which means, quick example, d over dx, x cubed, it's going to be equal to, if you just put this 3 out front, so out front of x, 3 times x to the power of, then you're going to decrease this degree by 1. So 3 minus 1, we get 2. Another example, d over dx, let's say x to the power of 10. So in this case, our degree is 10, so I'm going to put this 10 out front, so 10 times x to the power of, then I'm going to decrease the degree by 1, power of 9. Okay, and this is the power rule. The constant rule, sometimes we're going to see this polynomials, these monomials being multiplied by a constant number. So in this case, you can put this constant number out front and take the derivative of the function. So what I mean is, quick example, let's say we have d over dx 5x cubed. So what you're going to do is you're going to put this 5 out front and take the derivative of x cubed, which is 5 times 3x squared. Then you can multiply these two, you get 15x squared. Okay, and the next rule is sum and the difference rule. Okay, so when you are taking the derivative of this sum function or the difference function, it's going to be equal to also when you take the derivative of this function separately. Okay, so what I mean is, quick example, let's say we have d over dx x cubed plus x to the fourth. So this expression is going to be equal to d over dx x cubed plus d over dx x to the fourth. Okay, and now you can take the derivatives separately and you can put them back together. So we get 3x squared and plus 4x cubed. That's what it says right here. But we cannot apply these rules for product and quotient functions. So we're going to talk about those rules in the upcoming videos. Please stay tuned. So now let's do some practice. In question 1, we have f of x equals x to the power of 3 halves, which is a rational exponent, and we're going to find the derivative of this function and evaluate it at x equals 4. Let's do it. F prime x is going to be equal to whatever you have in the degree, you're going to put it down and put it out front of x. You get 3 halves. And times, you're going to decrease the degree by 1, which means you're going to subtract 1 from 3 halves. So once you subtract 1 from 3 halves, you get just 1 half. So x to the power of 1 half, or 3 halves times square root of x. So now we're going to evaluate this function at x equals 4, which means 3 halves times square root of 4. I'm just going to replace x by 4. And now we get 3 halves times 2, and now we get just 3 as an answer. Okay? For question 2, it says for question 2 3 differentiate each function. But notice that sometimes we may need to do something algebraically before we take the derivative, okay? Like these questions, okay? So first of all, f of x can be also written as 1 half times, and notice that I'm putting this constant number out front, so 1 half times x to the power of negative 2/3. So this whole thing can be written as like this. Okay, so now we can take the derivative. So the f prime x is going to be equal to 1/2 times, you're going to put this down over here, put it out front of x, so you get -2/3 times, you're going to decrease the degree by 1, so -2/3 minus 1 is going to be equal to -5/3, so we get -5/3. So if we are required to do some simplification, we have to do it. So we get -1/3, and if you don't want to deal with negative exponent, you can always put it convert it back into positive exponent. So you get 1/x to the power of 5/3 as our final answer. And number 3, so a prime of t is going to be equal to -1/2 times, and notice that there's plus sign, there's minus sign. Remember the sum and difference rule. So I'm going to take the derivative of this function separately and put them back together as a final answer. So -1/2 times 4 times t to the power of 3 and plus 9t squared and minus 2. Of course, we need to put our answer in the most simple way. So a prime of t is going to be equal to -2t cubed and plus 9t squared and minus 2. And that's going to be our final answer. And lastly, we have this question 4. Okay. So in question 4 it says find the derivative of this expression. This is the function, and evaluate it at x equals -1. So first of all, I would like to write all these answers in negative exponent with negative exponent. So we get d/dx, x to the power of -3 minus x to the power of -1 and plus x squared. So now I'm going to find the derivative. So we get -3x to the power of -4. Because you subtract 1, you get -4. And plus x to the power of -2 and plus 2x. So now I'm going to evaluate this answer at x equals -1, which means I'm going to switch all x by -1. So we get -3 times -1 to the power of 4 and plus -1 to the power of -2 and plus 2 times -1. And from there our answer will be -3 times -1/4 plus 1/-1/2 and minus 2. So this one is going to be apparently the positive 1 times -3, we get -3. And then we have positive 1 and minus 2. And our answer, final answer, will be -4. Alright guys, thanks so much for watching this video. See you in the next video. Please stay tuned.